Angular now comes with a command line interface to make it easier and faster to build Angular applications. Now, it should be noted that at the time of recording, which is October 2016, the Angular CLI project is still in beta, and a few things aren't completed, and also a few things might change by the time it reaches production. However, the CLI is a useful, if not essential, tool for building Angular applications. Now, we'll still be using Plunker for most of this course. That's because of Plunker's convenience in that I can give you a link with some source code and you can view it and run it straight away. And also so you can easily ask for help by sharing a link to your Plunker. We can't do that with a full-blown Angular CLI project. However, when you start building your own proper Angular projects, I expect you to use the Angular CLI. I use it for my projects and it saves a lot of time and standardizes the structure and layout of your Angular projects. The Angular CLI helps with bootstrapping a project. It creates the initial project structure with the root ng module and a root component and bootstraps it using the platform bootstrap dynamic method. You'll also find that the project is configured to use the Webpack loader, not the System.js loader that Plunker uses. The Webpack loader handles things like module loading, bundling, and minification of all of your code. Now, the reason we don't use Webpack in Plunker is that Webpack doesn't work with Plunker. Not because System.js is better than Webpack, but both of them are really doing the same thing. They're just bundling and minifying and transpiling our TypeScript code. The CLI also helps us with serving and live reloading. So the CLI starts a local web server and then we can view our application in the browser via localhost. And then the CLI also watches for any changes to our files and automatically reloads the web page if there are any changes. It also helps with code generation. So using the CLI, we can create components, directives, services, pipes, etc., all from the command line and all with the necessary files, folders, and boilerplate code included. And a really important fact is all of the generated code adheres to the official Angular style guide. Now in Angular 1, the Angular team never supported an official style guide. There was one or two really popular unofficial ones, but never an official one. And this meant that most projects ended up looking pretty different to each other. A developer moving teams would have to figure out from scratch how this team likes to write Angular 1 code. But by adhering to the official style guide, it now means that an Angular 2 developer will be able to start working on any Angular 2 project, well, any project that supports the style guide, and have a pretty good idea what's going on. So I recommend whether you use the CLI or not to adhere to the official style guide. And you can find the style guide at angular.io/style guide. The CLI also helps with testing, so the generated code also comes with bootstrapped Jasmine test spec files. And we can use the CLI to compile and run all the tests with a single command. And whenever the CLI detects changes to any of our files, it reruns all the tests automatically in the background. And with the CLI, we can also perform packaging and releasing. So the CLI doesn't just stop with development. Using it, we can also package our application ready for release to a server. So let's go ahead and install the CLI. To do that, we need to use Node, at least Node version 4, and the Node Package Manager, at least version 3. So we type npm install -g angular-cli, and we hit enter, and this might take some time to run, so I'll cut back to it when it's complete. So once this has installed, you should see an output like this. Now, just a quick note, if you did see a few warnings, they're not great, but they're safe to ignore. You only really need to be worried if npm reported an error. And if everything installed correctly, then you should have the command line tool ng available on your path. So if you type in ng-v, it should print out the version of the application that was installed. So we've installed the Angular CLI version 1 beta 18, and it has some other information about our version of Node. So now that we've got ng installed on our computer, let's create a new project called CodeCraft. And to bootstrap our new project with ng, we run this command. ng new and then the name of our project. Just a quick note, this is probably gonna take some time to run, so please be patient. And the command generates a number of files and folders for us. And so what I'm going to do is I'm going to open this up in my IDE WebStorm. And I'm just going to quickly discuss some of the files and folders that it generates for us. On the left-hand side, you can see the files and folders. If we look in the source directory and in the app directory, this is where you will probably be spending most of your time because your main application code goes in the app folder. Any assets for your application, such as images, for instance, we would put in the assets folder. The environment folder holds the settings for the different environments, for instance, dev, QA, production. Right now, it just comes with two environments, one for production and one for everything else, I suppose, so development. We have our main index.html file here, and we have our main.ts file here, which is our main TypeScript file, which kind of bootstraps everything else. We then have other kind of useful files. So we have the favicon, the styles, a test file. We have the tsconfig file, which we should understand now. It's the TypeScript configuration file for how to transpile TypeScript into JavaScript. We have our type definition file. The angular-cli.json is our configuration file for the Angular CLI. Karma configuration.js, this is the configuration for the Karma test runner. We'll cover Karma and Jasmine in a lot more detail in the section on unit testing. Package.json is our standard Node package file. Protractor configuration is a configuration file for Protractor, which is used in end-to-end testing in Angular. And we have a README file and a TypeScript linter file. And then up at the top again, we have this E2E folder, which stands for end-to-end testing. And this is where we would stick our files for our end-to-end tests. So this directory structure follows the recommended app structure and style guide. And as well as creating all of these files and folders for us, we can see from the package.json file that it also installed the correct versions of all of the required NPM dependencies for us also. And that's really why the create project command takes so long, because it's creating and downloading all of these required Node files and storing them on your computer as well. So far in this course, we have bundled all of our code into one file on Plunker for convenience. Let's see how the Angular CLI breaks up the code into multiple files and where those files are located. So if we look in the app folder at a bootstrapped app.component.ts file, this project is bootstrapped with one component, our root component, which is called app component. And it has a selector of app root. Don't worry about these other properties of the component decorator. We will go through them in the next section. So our selector is app root, and if we look at the index.html file, it has already added the app root tag as our root component. You'll also notice in the index.html file that there are no script tags present. That's fine. The Angular build process adds all of the required script tags and link tags for us. Then if we look at app.module.ts, this is where we will find our top level module configuration. So in here, in the declarations, we've got our app component, and in here we are bootstrapping our app component. And then if we look at the main.ts file, this is where we are actually bootstrapping our main app module using the platform browser dynamic function. So every application built using the Angular CLI will split up its code in this way. The main.ts does the bootstrapping, there'll be an app.module which has the module configuration, and then the code for each component will be in a separate file. Now I'm going to open up a terminal window in my IDE. So with the CLI, we can also easily serve our application using a local web server. We just run the command ng serve. This builds our application, bundles all of our code using Webpack, and makes it all available through the localhost 4200. So if we go to localhost 4200, we should see a very basic application with just the text app works. And it also watches for any changes in our files and recompiles the application automatically and then refreshes the server. So if I go to app.component, I change app_works to app_works_hey, press save. If we look in the terminal at the bottom, we would have seen that it rebuilt the application. And now if I open up the browser window again, it says app_works_hey. We didn't have to refresh the browser, it reloaded it for us. The ability to generate stub code is one of the most useful features of the CLI. And I think the most exciting part of this is that it automatically generates code that adheres to the official style guide. With the generate command, we can create new components, directives, pipes, services, classes, interfaces, and enums. Each of the above types of things it can create is called a scaffold. And we can run this command using ng-generate, the name of the scaffold, and the name of the thing that we want to generate. So if we wanted to generate a component called header component, we would write ng-generate component and then just the word header. And then if we look in our app folder, this creates a number of files in a folder called header. If we take a look at the header component.ts, we can see it actually named our component header component. So that's an important thing to know about the CLI, especially when using the generate command for component. Don't type ng-generate component header component, because then it will create a class called header component component. So just remember to call it ng-generate component header, and don't put the component at the end of your name. Now it only does this for components and directives. For the other things that we generate, you actually need to provide the full name of the class that you're going to be creating. Now that command could actually be shortened to ng-component header. And that's what we'll be doing for the rest of this lecture. Now, if we run the command in an app folder, the generate command will create files relative to the current folder you are in. So if we were in, let's say, source app header, and then we created another component, it generates that component relative to the folder that we're in. So it creates it under the header component. Also notice what it does to the folder name. So we wrote login capital L, capital B button. Whenever it detects something camel case like this when creating folders, it will replace it with a dash. So login dash button. Because the button in login button, the B is capital. So when creating a folder, it just puts it lowercase and puts a dash in front of it. We can also be explicit about where we want the generated files to go. If we ran ng component and then we put the path to where we want the generated files to go, so I'm saying I want it to go under login button and then bar-foo. This then creates a component under login button, and then if we look at the bar-foo component, you can see it's converted the dashes to camel case, to bar, capital foo, capital component. So let's have a look at some of the other scaffolds that we can use in the Angular CLI. Now, we've covered components before in the application, and for the rest of these scaffolds, I'll be covering things that you haven't seen yet, but you will see them in the rest of the course. So the first thing I'm going to show you is how to create a directive. And a directive, again, we're going to cover in the rest of this course. So we type ng, G for generate, directive, and then the first part of the directive name, which I'm saying is my. It's created a directive called my.directive.ts, and the name of the class is my directive. So again, don't provide the name my directive as the last parameter because the Angular CLI adds the word directive automatically. We can also create something called a pipe. I'm just going to type ng, G for generate, pipe, and then my. And then it created a file called my.pipe.ts, open it, and again it's created a class called myPipe. So there was no need to provide the word pipe at the end of my. So we can also generate something called a service. And again, we'll go through services later on in this course. And again, it's just created a class called myService. So there was no need to provide the text service. As well as these higher level scaffolds, we can also just create normal classes. So that created a file called my-class. And unlike everything we've shown you so far, when you create a class, you actually provide the full name of the class on the command line. It doesn't append anything to it. We can also create an interface. And again, we provide the full name of the interface on the command line. And we can also create an enum. And as you might guess, we provide the full name on the command line. Now that's all the scaffolds we currently have with the Angular CLI. Now the ngserve command, which I showed you before, does a great job of enabling you to develop locally. However, eventually you will want some code which you can host on another server, on another site somewhere. Now the Angular CLI can help us with this. If we want to create a development build, we can simply type ng build. Now this bundles all of our JavaScript, CSS, HTML into a smaller set of files, which we can host on another server. So that's worked successfully. So now if we go back into our project, we will now find a folder called dist, which we can open. And here we can see our index.html file. And you can see it's injected into our index.html file some script tags. So the inline, style bundle.js, and main bundle.js. And it's bundled all of our code into several files. So the main one being main.bundle.js. So let's have a look at this folder. So it's got a bunch of files in there. Now these files are ready to be deployed on any server anywhere. I'm just going to quickly run up a local web server using Python-m simple HTTP server. If you've got Python installed on your computer, you will always be able to just open up a simple web server using this command. And now if I go to my computer, port 0000, port 8000, there we go. You can see our app is running in the browser. So all you now need to do to release your application somewhere is just to copy this folder on some web server and serve this folder. And that's all you need to do. But if we take a look at this folder, we can see that a lot of these files are really pretty big. So we've got a 2.4 megabyte main.bundle.js. And that's because this is a development build. If we wanted to create a production build where a lot more of the code is optimized, we would type ng build -- prod. Okay, now that's created our folder again. Now if we look at our dist folder, let me open and close. You can see it looks a little bit different. We still seem to have similar files, but they have longer names with these kind of random letters and numbers interspersed and in between the name. Now this is to enable something called cache busting, and that ensures that a browser doesn't try to load up previously cached versions of the files and instead load up the new ones from the server. And if we take a look at the file sizes, we can see they are much, much smaller. So the main bundle.js is now 794K, and the gzipped version of it is 181K. So that's what this .gz file is. It's a zipped up version of your JavaScript file. And most browsers, when you request a JavaScript file, will actually first check to see if there's a zipped up version of that file available on the server. And if there is, it will download the zipped up version of it. Because downloading a zipped up 181K and then unzipping it on your computer is actually faster than just downloading the unzipped 794K. So if a browser sees a zipped up version of a file, it will always try and download that one first. So the build system simplifies the process of serving and releasing your application considerably. It works only because Angular knows all about the files used in your application. So when we include third-party libraries into our application, we need to do it in such a way that Angular knows about the libraries and knows to include them in the build process. So if we want to include a module to use in our Angular JavaScript code, perhaps we want to use the moment.js library, we just need to install it via npm. But the important thing is to make sure you add --save to the end, because when we install it with --save, it adds it in to the package.json file. And Angular looks at the package.json file to figure out what to bundle. And if we also wanted to include the TypeScript type definition file for our moment module, we can install it like so. npm install @types/moment-save. Now, when Angular creates a build, either when releasing or serving locally, the moment library is automatically added to the bundle. But what about global library installation? Some JavaScript libraries need to be added to the global scope and loaded as if they were in a script tag. We can do this by editing the Angular CLI JSON file in our project root. The Twitter Bootstrap library is a great example of this. We need to include the CSS and script files in the global scope via link and script tags. First, we install the Bootstrap library via npm, like so. And then let's open up our Angular CLI JSON file, this one. Let's get some space. And we find the styles section, and then let's add the CSS file for Bootstrap that we've just downloaded. So I'm going to add it here. There we go. And we also need to add the required script files for Bootstrap. So I'm going to add that into the scripts property there. There we go. So now if I cd out, let's do a build again. Now when the build runs, the CLI includes those files in the bundle and injects them in the global scope. So regarding testing, Angular has always been synonymous with testing, and so there should be no surprise that the command line tool comes with features to make Angular testing easier. So the default testing mechanism for unit testing in Angular is via Jasmine and Karma. Whenever we generate code via scaffolds, it also generates a .spec file. So if I look at any of our files really, so even our mypipe.spec file, it's actually created a stub Jasmine test file, which you can then flesh out with more information and more test cases. Now we'll be going into unit testing. There's a whole section on unit testing at the end of this course, so we won't go into it in any more detail right now. But we can run all of our unit tests with one command, ng test. This builds our project and then runs all of the tests, and any errors are output to the terminal. Now just a quick note, when you run this command, it creates a browser instance like this. This is Karma. Don't close it when you're running the tests. But again, we'll go into this in much more detail in the section on unit testing. So in summary, we've covered the overview of the main commands and the default features. To find out more details about each command and how we can customize the behavior via flags, we can run ng help in the terminal. By handling the setup for us, the command line interface has made working with Angular much easier. By standardizing setup and structure, it's also made Angular projects fungible. Angular developers who are used to the Angular CLI should feel comfortable on all Angular CLI projects.